What up, mathletes? Whoop, whoop. All right, let's do this. All right, we're ready. So this is the warm-up. Simplify each expression. Yeah, I should have erased that. That's from. I just forgot to erase that. Solve the following systems. That's what it should say. And don't forget today's learning target, which is I will use elimination with multiplication. Dangerous. Go ahead and solve the system. You should be able to do it with just your normal garden variety elimination. Pause it. Let's make some more coffee. All right. You guys ready? Hopefully, we're coming off a pause here. Might as well watch me put stuff in the microwave. Okay. So let's solve this, right? It's already step one. Add straight down, I get negative 3x equals negative 9. Divide both sides by negative 3. Bada bing, bada boom. X equals positive 3. All right, let's move on to, and that was step 2, by the way. Let's move on to step 3, which says to plug that back in. And I always plug it into the top equation, right? So I'm going to have 5 times 3 plus 2y equals negative 1. 15 plus 2y equals negative 1. And minus that 15 from both sides. And 2y equals negative 16. Divide both sides by 2. Y equals negative 8. Boosh. But that's not our answer. Oh, no, little Padawan. It is an ordered pair, which is 3, negative 8. Now, let's check our colon in the bottom one. So in the bottom, negative 8 times my x value of 3 minus 2 times my y value of negative 8, and hopefully that will equal negative 8. So negative 8 times 3 is negative 24. 2 negatives make a positive, plus 16 equals negative 8. Negative 24 plus 16 is negative 8 equals negative 8. Is that true? Yes, it is. Check. We checked it. All right. Time for writing down the elimination method using step 1. Multiply. Oop, coffee's done. Multiply at least one equation by a constant. So multiply at least one equation by a constant. To get 2 equations that contain opposite terms. Awesome. So multiply at least one equation, EQ stands for equation, by a constant to get 2 equations that contain opposite terms. All right? Step 2, add the equations together. Add the equations together and solve for the remaining variable. VAR is my short for variable. And then last but not least, step 3. Sub the value from step 2 and solve for the other variable. I'm going to write this as an ordered pair. Let's write answer as an ordered pair. An XY, right? Awesome. Pause this, zoom in, whatever you got to do. I guess I can zoom in for you. Does that look better? Pause right here if you need to. We're moving on. It's not meant to be long today. All right, we're going to solve the system using multiplication. It's actually not bad once you get used to it. So we're just looking at these. They're already lined up. Now, looking at the x and the y, first of all, I do see that these are opposite, right? But is it easier to turn a 3 into 5 or a 5 into 3 or a 5 into a 10? What's easier? Well, turning a 5 into a 10, how do we make 5 10? We multiply it by what? By 2. So I'm going to actually multiply. Now, they're unfortunately both positive, so not just a 2, but I need to multiply by a negative 2. That way I can make this opposite and equal. Are you ready? So first of all, let's rewrite the top. 10x plus 5y equals 30. Now distribute this negative 2 through the whole thing, right? Negative 2, negative 2. I'm going to end up with negative 2 times 5x is negative 10x. See, we have our equal and opposite now. Negative 2 times negative 3y is positive 6y. And negative 2 times negative 7 is positive 14. Okay. Now we're going to add straight down. So this was step 1. And add straight down. X's are gone. I have 11y equals 44. Oh, that's nice. Divide both sides by 11. Y equals 4. Okay? Now let's go on to, that was step 2. We're going to do step 3 over here. We're going to plug that 4 into the top equation. So I have 10x plus 5 times 4 equals 30. And let's finish that out. That's going to be 10x plus 20 equals 30. Subtract that from both sides. 10x equals 10. Divide the sides by 10. And we have x equals 1. Or the ordered pair, 1, 4. Now, of course, I like to check it. Check the colon in the bottom. So, for the 1, 4, ordered pair of 1, 4, we're going to have 5 times 1 minus 3 times 4. Now, notice I'm using the original equation right here. Okay? Equals negative 7. So, what is that? 5 minus 12 equals negative 7. 5 minus 12 is negative 7 equals negative 7. Check. We are done. That was good stuff. So see how we did that? Not too terrible. When it's set up like this, it works out really nice. You just multiply one of the equations, make it work. Pause this if you need to. We're going to move on because our next two problems are a little bit more complicated than that. Because multiplication... All right. If you notice a little blip, sorry about that. I made an error. So if your paper has a negative 11 right here, make sure and change that to a positive 11. That's going to change the world. I worked this out. It was like the worst problem ever. And I was like, oh my goodness. So let's do it the way it was meant to be done. But basically, if we look at this, neither one of these, I can't really turn a 5 into a 7 or a 6 into a 5 or vice versa. So what we're going to have to do is just pick which one of these we think is easiest and multiply, find a number that both of them will fit into. Well, I know 5 and 6 will both go into 30. And I can accomplish that by multiplying the top here by 5 and the bottom here by 6. Notice what I did. I just took this number and multiplied it times the whole bottom, took this digit and multiplied it times the whole top. And when we do that, let's rewrite our equations. We end up with 25x minus 30y. I have to move this over a little bit. Is equal to 55. And down here, what do we get? Our negative 42x plus 30y equals 30. This is going to be so much better. You can trust that. So what do we have here? We have negative 17x. This goes away equals 88. Again, right here, 55 plus 30, let's make no mistake, is 85, not 88. I don't know what's happening in my head, but let's finish this out. Divide both sides by negative 17, and we get that x equals what? Negative 5? That works out so much nicer than last time. We're talking something like, I can't remember. It was like 25 seventeenths, right? It was terrible. So this is x equals 5. That's why we want to make this a positive 11 on this question. Okay, now we're going to take this and we're going to plug this back into the top equation. I'm just going to plug it into the original top equation. We're going to have 5 times our x value of negative 5 minus 6y equals 11. So negative 25 minus 6y equals 11. Add that 25 to both sides. Oh, so much better. The answer to this one was originally, the way I had done it with that negative 11, was 69 seventeenths. That's not a great answer. This becomes negative 6y equals 36. Divide both sides by negative 6. And we get that, y is equal to negative 6. And our ultimate answer is the ordered pair, negative 5, negative 6. Much, much better. We're still going to do a little check here. We want to check our colon in the bottom equation. So we're going to have negative 7 times our x of negative 5 plus 5 times our y of negative 6 equals 5. So let's do it. That's going to be 35. 5 times negative 6 is minus 30 equals 5. And 35 minus 30 is indeed 5. Does equal 5. Check. Wow, that was better than the last one I did. Okay, got a little bit of a small area left, but we're going to try to see if we can fit everything in. Let's see if I can do this using the least amount of room possible. Looking at this, I'm just going to, notice these are the same. These are opposite, so if I have to multiply both equations, might as well make the ones that are already opposite signs work. So I know 3 and 2 both go into 6, so I'm going to multiply the top here by 2 and the bottom equation by 3, and I end up with what? 6x plus 8y equals times 2, negative 44. Okay, and for our bottom equation, negative 2 times, or negative 6x, 3 times 3y is plus 9y, equals 3 times negative 8 is negative 24. We're just going to add these straight down again. X's go away. I'm left with 17y equals negative 68. And when I divide both sides by 17, believe it or not, that ends up being y equals negative 4. Not bad. Well, let's plug it back into the top equation. 3, it's just times x, I forgot to solve for y, plus 4 times our y value of negative 4 equals negative 22. So 3x minus 16 equals negative 22. Let's add that 16 to both sides. 3x equals, is me with what? Negative 6. Divide both sides by 3. X equals negative 2. And our final answer is the ordered pair. Negative 2, negative 4. You're thinking we don't have room for a check. But au contraire, yes we do. We have room right here. So for check our colon in the bottom equation, we're going to have negative 2 times our x value of negative 2 plus 3 times our y value of negative 4, and that should equal negative 8. So that's positive 4, minus 12 equals negative 8. And 4 minus 12 is indeed negative 8, which equals negative 8. Check. Boom! Look at that. That's some good math done today. So use that multiplication, crush this. Remember, we start studying for our test next. So this is a quick turnaround assignment, but it's just a little bit of a switch on the elimination method. With that said, peace out. Bye, guys.